Have you ever rested your hand against the rough bark of an ancient oak tree, or pressed your palm flat against a cold glass window, and wondered why everything in the universe feels so undeniably, perfectly solid? We navigate our lives through a world of tangible objects. We trust the firmness of the ground beneath our feet, the unyielding strength of the walls that shelter us from the storm, and the comforting weight of a warm cup of tea resting in our hands. This physical reality seems absolute, unquestionable, and completely self-evident. You are used to density, to things being close together, to the world being full. We move through our days surrounded by a symphony of textures, temperatures, and physical resistance, never pausing to question the fundamental nature of the material that makes up our existence. But what if I told you that this overwhelming sensation of solidity is, at its most fundamental level, an exquisite cosmic illusion? What if the very fabric of the reality you interact with every single day is actually made of almost entirely nothing at all, held together by ghostly entities that might not even possess a definite shape or a fixed location? The physical world you know is hiding a secret so profound that your brain will struggle to truly understand it. This is not an exaggeration. This is not dramatic storytelling. This is the honest truth about the hidden architecture of our universe. A truth just as mind-bending as the existence of a cosmic monster that sits over 1 billion light years away from us, quietly existing in the darkness of a space, holding more stars than you could ever count in 1 million lifetimes. The microscopic world is just as terrifyingly vast, just as mysterious, and just as deeply beautiful as the grandest scales of the cosmos. Hello, I am Walter, the Explorer. Before we dive deeper into this quiet journey of the mind, I want to take a brief moment to invite you to join our growing community of cosmic explorers. Our analytics show that 73% of the people who watch our videos are not subscribed yet. If you enjoy learning about the strangest and most mind-bending things in our cosmos, please consider subscribing to the channel. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Now, let us return to the mystery of the solid world and the silent, invisible phantoms that create the illusion of substance. To understand what an electron really is, we must first embark on a gentle journey inward, leaving behind the macroscopic scales of everyday human experience and descending into the microscopic depths of matter. Imagine for a moment that you possess the ability to shrink continuously and smoothly, diving deeper and deeper into the structure of a simple object, perhaps a single grain of sand resting on a vast beach. As you shrink, the smooth surface of the sand grain begins to look like a rugged landscape of mountains and valleys. You continue to shrink, and those mountains resolve into massive, repeating structures of crystalline architecture. These are the molecules, bound together in a quiet, eternal dance. But we must go deeper still, far beyond the realm of molecules, into the individual atoms themselves. For most of human history, we assumed that what we could see and feel was everything. The ancient philosophers of Greece told stories of tiny, indivisible building blocks of reality, calling them atomos, meaning uncuttable. They imagined reality as a collection of infinitesimally small, solid spheres, much like miniature billiard balls, packing tightly together to form the infinite variety of the material world. This intuitive idea provided comfort, a sense of order and mechanical predictability in a chaotic universe. It was a beautiful, elegant theory that held sway over the human imagination for centuries. But the universe is vastly more strange, more mysterious, and more wonderful than our earliest ancestors could ever have anticipated. When the first modern scientific instruments were turned toward the hidden inner world of matter, much like when the first telescopes were turned toward the hazy band of the Milky Way in the 17th century, observers began to realize that the fundamental nature of reality was far more complex and far more sparse than anyone had ever imagined. As our scientific tools grew sharper, the solid billiard ball model of the atom shattered into pieces, giving way to a reality that resembles a vast, silent emptiness. To truly appreciate the nature of the atom, we must invoke the same sense of scale that we use when contemplating the most enormous structures in the cosmos. Let me set the stage for you. Imagine you are standing in the center of an unimaginably vast, empty warehouse. If you were to take the nucleus of an atom, the tiny, dense heart, where almost all of its positive charge and mass are concentrated, and enlarge it until it was the size of a glass marble, resting perfectly still on the ground in the exact center of that warehouse. The outer edge of the atom, the boundary where the electrons reside, would be several miles away. The space in between would be essentially void, just the faintest whisper of energy and invisible electromagnetic fields. This emptiness is hard to wrap your mind around. Step outside our ordinary macroscopic perspective, and emptiness becomes the rule. In fact, the space between the nucleus and the electron is so unimaginably empty that if you were to remove all the empty space from every single atom in the bodies of all 8 billion human beings currently living on Earth, the remaining solid matter, the actual physical substance of all of humanity combined, could be compressed into a space smaller than a single cube of sugar. You, me, the towering mountains, the deep oceans, the distant stars, and the massive galaxies, all of it is overwhelmingly composed of absolute nothingness. The solid weight you feel when you hold a stone in your hand is not the feeling of physical matter touching physical matter. The electrons in the atoms of your hand are violently repelling the electrons in the atoms of the stone through the fundamental force of electromagnetism. When you sit on a comfortable chair, you are not actually touching it at all. You are, in reality, levitating a microscopic fraction of an inch above it, suspended in midair by the invisible repulsion of electron clouds. The sensation of physical touch is simply your brain interpreting the electromagnetic resistance between these ghostly microscopic entities. But what exactly are these entities? What is this electron that defines the very boundaries of the material world, that gives shape to the emptiness, and that binds atoms together in the quiet, endless chemistry of life? For a long time, scientists pictured the electron using a conceptual model that felt deeply familiar, a model drawn directly from our observations of the night sky. We imagined the atom as a miniature solar system. In this model, the heavy nucleus sits at the center, playing the role of the sun, while the tiny, negatively charged electrons orbit around it like microscopic planets, tracing precise, predictable paths through the inner void. It is a comforting picture, one that mirrors the majestic clockwork of the heavens. It is easy to picture, easy to understand, and deeply embedded in our cultural imagination. You have probably seen it depicted countless times in textbooks, scientific logos, and popular media. However, just as our understanding of the cosmos shifted dramatically when astronomers realized the Milky Way was not the entire universe, and that countless other island universes drifted in the dark, our understanding of the microscopic world underwent a profound and deeply unsettling revolution. The planetary model of the atom, despite its undeniable elegance and its intuitive appeal, is completely, fundamentally, and unequivocally wrong. The electron is not a tiny, solid sphere of electrical charge. It is not a microscopic planet traveling along a defined, predictable orbit around a central sun. It does not have a precise location that you can point to. It does not possess a clear physical boundary, and it does not follow a predictable trajectory through space. As human knowledge descended into the strange and counterintuitive realm of quantum mechanics, the very concept of shape, size, and position began to dissolve into a strange, beautiful haze. The electron forces us to abandon our classical, common-sense intuitions and step into a reality where probability replaces absolute certainty, where waves behave curiously like solid particles, and where particles blur into sprawling, undefined waves. It is a world where an object can seemingly exist in multiple places at the exact same moment, only choosing a definite state when it is forced to interact with the outside universe through an act of observation. This shift in perspective is as profound as discovering that our home galaxy is just one tiny speck of dust floating among 2 trillion other galaxies in the observable universe. Consider for a moment what it truly means to not have a definite size or shape. If you were to ask a physicist for the exact dimensions of an electron, they would tell you that, according to our best mathematical models, it is a point particle. This means that it has no physical volume whatsoever. It takes up absolutely zero space, yet this infinitesimally small, sizeless entity carries a defined mass and an electrical charge that projects an invisible field extending infinitely outward into the universe. How can something that occupies no physical volume have mass? How can something with 0 dimensions influence the macroscopic world so profoundly? These are not just mathematical curiosities. They are profound philosophical questions that strike at the very heart of existence. When an electron is not interacting with anything, it does not exist as a tiny dot sitting in a specific location waiting to be found. Instead, it exists as a sprawling, diffuse cloud of pure mathematical probability. It is a wave of potential smearing itself across space, existing everywhere and nowhere simultaneously, until the exact moment it is measured or observed. In the profound silence of the quantum realm, the electron is less like a physical object and more like a musical note waiting to be played, a ghost of a possibility haunting the empty spaces inside the atom. It is an ethereal presence that defies everything your intuition tells you about how the physical world should operate. And yet, it is precisely this ghostly, undefined nature that gives the material universe its structure, its stability, and its incredible diversity. Without the wave-like spread of the electron, atoms would immediately collapse. and the universe as we know it would cease to exist in an instant. The true nature of the electron is one of the most magnificent and persistent mysteries in all of modern science. It challenges our deepest, most closely held assumptions about what it means for something to be real. As we continue this quiet journey together over the course of our time, we will explore how this tiny, enigmatic entity governs the behavior of absolutely everything around us. We will see how it creates the light we see, the chemical bonds that make complex life possible, and the very illusion of the solid world we inhabit and move through every day. But for now, as we conclude this initial step into the unknown, I ask you to hold on to this profound thought. The solidity of your world is a beautiful mirage, a trick played on your human senses by invisible fields of energy and silent clouds of probability. You are a vast collection of empty spaces held together by ancient forces and mysterious particles that dance continuously in the dark. The universe builds things from the bottom up, starting small and growing large through countless interactions over cosmic time. The electron is the foundational brushstroke in this cosmic masterpiece, a tiny whisper of reality that echoes across the infinite expanse of space and time. It is a monument to the forces that shape our universe and to the processes that have been building complexity ever since the first atoms formed. Let us pause here in the quiet realization of our own beautiful emptiness, allowing the mind to rest before we take the next step into the strange quantum heart of the electron and attempt to grasp the ungraspable. Have you ever sat beside a perfectly still lake under the velvet canopy of a night sky, watching a gentle breeze create soft ripples across the dark water? If you throw a single small stone into that quiet pond, you see a perfect circle of waves expanding outward, smoothly gliding across the surface until they fade into the shadows. Now, imagine taking a handful of sand and tossing it into the same water. You know that each tiny grain is a distinct, solid object, a tiny particle of earth. We easily separate the world into these two distinct categories: waves, which are continuous ripples of energy flowing through space, and particles, which are discrete, solid chunks of matter. This division seems as natural and undeniable as the difference between the bright burning stars and the vast empty darkness that separates them. But as we continue our journey into the deepest, most ancient layers of reality, we find that the universe refuses to be neatly categorized by our simple human intuition. When we ask the cosmos what an electron is, whether it is a solid grain of sand or a spreading ripple of water, the universe answers with a quiet, perplexing paradox. It tells us that the electron is somehow impossibly both. Hello again. I am Walter, the explorer. As we wade deeper into this ocean of quantum mystery, I want to gently remind you that our journey is made possible by the quiet support of curious minds like yours. Our records show that 73% of the people who watch our videos have not subscribed yet. If you are finding peace and wonder in these cosmic explorations, please take a moment to subscribe to the channel. It helps us tremendously and ensures we can continue to share these quiet journeys into the unknown together. Now, let us return to the mystery of the wave and the particle and the experiment that shattered our understanding of the physical world. To truly understand this profound mystery, we must look back to an experiment that has been described as one of the most beautiful and deeply unsettling in all of science. It is known as the double-slit experiment. Imagine a source of light, gentle and steady, shining toward a solid barrier. In this barrier there are two narrow vertical slits sitting side by side. Behind the barrier is a blank screen, waiting in the silence to record whatever passes through. If light were made solely of tiny solid particles like microscopic bullets, you would expect them to travel in straight lines through the two slits and hit the screen directly behind them, forming two bright parallel bands of light. But that is not what happens. Instead, when the light passes through the two slits, it creates a beautiful, repeating pattern of alternating bright and dark stripes spread across the entire screen. This is an interference pattern, and it is the undeniable signature of a wave, just like two ripples in a pond intersecting and creating a complex pattern of peaks and troughs. The light waves pass through both slits simultaneously, interfering with each other in the quiet space before hitting the screen. For a long time, this was a settled matter. Light was a wave spreading across the vast cosmos, carrying ancient stories from distant stars. Matter, on the other hand, was made of particles. Electrons, those tiny entities orbiting the heart of the atom, were definitively categorized as solid, discrete particles. But in the early 1920s, scientists decided to perform this exact same experiment, not with a beam of light, but with a beam of electrons. They built a microscopic version of the barrier with two slits and set up a sensitive detector screen to catch the electrons. The expectation was completely straightforward. Since electrons were particles, little chunks of solid matter, they should behave like tiny bullets. They should pass through one slit or the other and create two simple bands on the detector screen. But the universe, in its infinite elegance, had a different story to tell. When the scientists fired the beam of electrons through the two slits, they did not see two bands. Instead, as the electrons struck the screen one by one, a ghostly, impossible pattern began to emerge from the darkness. It was an interference pattern. Alternating bands of high and low impact spread across the screen, exactly like the pattern created by waves of light. The scientific community was thrown into a state of profound shock and wonder. How could solid particles of matter create a pattern that can only be made by waves? The mystery deepened even further when the experimenters decided to slow the process down, firing the electrons one at a time with long pauses of silence in between. One single electron would be fired, traveling through the dark vacuum towards the slits. It would hit the screen with a tiny, solitary flash. Then another would be fired, and another. For a while, the flashes seemed completely random, like stars appearing one by one in the evening sky. But as hours passed, and thousands of individual electrons completed their quiet journey, the accumulated flashes slowly built up the exact same repeating pattern of alternating stripes. Let that sink in for a moment. This is a truth so profound that your brain will naturally struggle to accept it. A single electron fired completely on its own, with no other electrons around to interact with, somehow travels through the barrier and contributes to a wave interference pattern. For this to happen, the single electron must act like a wave of water. It must travel through the empty space, reach the barrier, and pass through both the first slit and the second slit at the exact same time. It then must interfere with itself in the quiet void before finally deciding where to land on the screen as a single solid point of impact. It is a particle when it is fired, a wave as it travels through the infinite possibilities of space, and a particle again the moment it is detected. The legendary physicist Richard Feynman once said that this single experiment contains the only mystery of quantum mechanics. It lays bare the fundamental, inescapable strangeness of the universe. When an electron is not being directly observed, it does not exist as a tiny, hard sphere in a specific location. Instead, it exists as a wave of pure probability, a gentle ripple in the fabric of reality, spreading out through the cosmos and exploring every possible path simultaneously. It is everywhere it could potentially be, all at once, existing in a state of quiet potential. The electron is a ghost haunting the empty corridors of the atom, waiting for the universe to demand its presence. But here is where the story becomes truly mind-bending, introducing a philosophical paradox that scientists and thinkers have wrestled with for nearly a century. If the electron travels as a wave of probability, passing through both slits at once, what happens if we place a tiny, gentle detector right next to the slits to watch it? What if we simply try to observe which path the electron actually takes? When scientists perform this version of the experiment, placing a measuring device to peer into the microscopic darkness, the universe instantly changes its behavior. The very act of observing the electron forces it to make a choice. The ghostly wave of probability instantly collapses. The electron passes through only one slit, just like a normal solid particle, and the beautiful interference pattern on the back screen completely disappears, replaced by two simple, boring bands. The universe knows when we are looking. The simple act of human observation, the gentle quest for knowledge, fundamentally alters the physical reality of the electron. In the vast, silent theater of the cosmos, matter behaves as an expansive, interconnected wave of infinite possibilities as long as it remains hidden in the dark. But the moment we shine a light on it, the moment consciousness reaches out to touch the fabric of reality, the wave collapses, and the universe forces the electron to choose a definite location. It is as if the cosmos is a shy and secretive artist, only revealing its true, continuous wave-like nature when it believes no one is watching. This revelation brings us to the edge of a profound existential cliff. We are made of these exact same electrons. The atoms in your hands, the neurons firing in your brain to process these words, the ancient rocks beneath your feet, and the distant glowing stars that fill the night sky are all constructed from these ghostly entities that hover in a state of undefined probability until they are forced to interact. Does this mean that reality itself is deeply intertwined with the presence of an observer? Does the universe require consciousness to bring its infinite possibilities into sharp, solid focus? These questions do not have easy answers, They are part of the grand, unending mystery of the cosmos. Just as we gaze up at the night sky and feel a sense of profound humility in the face of the estimated 2 trillion galaxies in the observable universe, we must also look inward into the hidden architecture of the electron and feel that same sense of respectful awe. The boundaries between the observer and the observed, between the solid particle and the flowing wave, and between human experience and the physical universe are not sharp lines drawn in stone. They are soft, blurry edges fading into the gentle unknown. We are not just passive observers sitting outside the universe looking in. We are the universe observing itself, participating in the quiet collapse of endless possibilities into the singular reality we experience right now. As we move forward in our journey, we will explore even deeper layers of this cosmic puzzle. We will venture into the strange forces that bind these ghostly waves of probability into the solid structures we call home. But for now, take a deep breath and let the silence of the night wash over you. Think about the billions of electrons dancing in the space around you, spreading out like gentle ripples on a quiet pond, holding the secrets of the universe in their invisible embrace. They are ancient, they are infinite, and they are beautiful. Have you ever tried to catch a falling autumn leaf in the palm of your hand? You stand beneath an ancient tree, watching a single leaf detach from a high branch, swirling on invisible currents of air. You can guess roughly where it might land, but its exact path is a chaotic mystery until the moment it touches your skin. Now, imagine a leaf that exists in every possible location around the tree at the exact same time, deciding on a single position only the very moment you reach out to grasp it. This is the staggering reality of the electron inside every atom of your body. It defies classical understanding of motion, challenges our intuitive grasp of location, and forces us to abandon the comforting image of a predictable universe. We must step out of the absolute certainty and walk gently into the shadow of infinite potential. Hello once again. I am Walter, the Explorer. As we venture further into this quiet journey through the microscopic cosmos, I want to take a brief moment to speak directly to you. Our analytics indicate that 73% of the people who watch our videos have not subscribed yet. If you are finding value in these peaceful explorations of scientific mysteries, please consider subscribing to the channel. It helps us tremendously and ensures that we can continue to uncover the profound secrets of the universe together. Now, let us return to our ghost in the atomic machine and the fundamental law of nature that strictly forbids us from ever truly knowing it. In the late 1920s, a brilliant physicist named Werner Heisenberg discovered something profoundly unsettling that shook the foundations of human knowledge. He realized that the universe possesses a built-in limit to what can be known. Even if we had a perfect microscope designed by a supreme cosmic intelligence, we would still be utterly blind to the objective truth of the electron. This concept is known as the Heisenberg uncertainty principle. It states, with unyielding mathematical precision, that you cannot simultaneously know both the exact position and the exact momentum, meaning the speed and direction of a microscopic particle like an electron. If you measure precisely where an electron is at a given moment, you completely lose all information about how fast it is moving or where it is going next. Conversely, if you measure its speed with perfect accuracy, its physical location smears out into an infinite, unknowable haze of possibilities. The universe demands a sacrifice of knowledge. You can know one aspect of the microscopic reality or the other, but you can never know both at the exact same time. This is not a human error or a temporary gap in our understanding. It is a structural feature of the cosmos itself. The electron stubbornly refuses to be pinned down by our classical definitions. It demands a quiet, respectful distance, a privacy that the laws of physics stringently enforce. Because of this inescapable uncertainty, scientists had to discard the comforting image of the atom as a tiny, precise solar system. We can no longer picture electrons traveling in neat, circular orbits around the central nucleus, much like the Earth travels faithfully around our Sun. Instead, they exist in what quantum physicists call probability clouds, or atomic orbitals. These orbitals are not physical objects with hard, defined edges. They are three-dimensional regions of empty space, where an invisible electron is statistically likely to be found if we force the universe to reveal its location. Imagine a swarm of 1 trillion invisible bees buzzing furiously around a delicate flower in the dark. You cannot point to any individual bee, but you can describe the overall shape of the buzzing swarm. These probability clouds take on incredibly beautiful, highly complex mathematical shapes that govern the entire physical world. Some are perfectly spherical, wrapping around the dense nucleus like a series of concentric, invisible shells. Others look like three-dimensional dumbbells stretching out into the void, or elegant, multi-lobed flowers blooming in the microscopic darkness of the atom. The most crucial thing to understand is that the electron does not simply move rapidly through these complex shapes. In a very real, quantum sense, the electron actually is the shape. It is a smeared-out wave of existence, filling the entire volume of the orbital simultaneously. It is everywhere within that mathematical boundary, and nowhere specific, all at once, suspended in a state of quiet, vibrating potential. Think about the scale of this microscopic architecture. If the nucleus were the size of a solitary marble on the floor of a massive warehouse, the electron cloud would extend for several miles. Within those miles of vast empty space, these intricate probability clouds layer on top of one another, creating a complex topography of energy. This invisible topography is the language of reality. It dictates the unbreakable rules of chemistry. When two atoms approach each other in the silent void, their dense nuclei never touch. It is these ghostly, mathematical clouds of probability that gently reach out and overlap, intertwining their wave functions to form the chemical bonds that build the universe. The cool water you drink, the fresh air you breathe, the ancient strands of DNA that carry the code of your existence, all these miraculous structures are held together by the quiet probability clouds of countless unknowable electrons. The revered astronomer Carl Sagan once famously said that we are made of star stuff. The heavy atoms in your body were indeed forged in the fiery hearts of ancient stars that lived and died billions of years before our sun was born. But as we peer into the quantum abyss, let us deepen that beautiful thought. You are not just made of star stuff. You are made of mathematical probabilities. You are constructed from billions upon billions of overlapping waves of infinite potential, microscopic clouds of uncertainty that miraculously interact in just the right way to create a conscious, breathing human being capable of wondering about its own existence. The solid illusion of your physical body is generated entirely by the complex geometry of entities that fundamentally refuse to be definitively located. This brings us to a deeply beautiful, highly meditative realization about the nature of the cosmos. The uncertainty that governs the electron is not a chaotic flaw in the universe. It is not a mistake in the cosmic code. It is the very source of its magnificent stability. If electrons behaved like classical particles, if we could know their exact position and speed simultaneously, they would inevitably spiral inward, losing energy, and crash into the nucleus in a fraction of a second. Every atom in the universe would instantly collapse. The universe would be nothing more than a dark, lifeless singularity. It is precisely because the electron is deeply uncertain, because it insists on smearing itself out into a vast wave of probability, that it naturally resists the overwhelming pull of the nucleus. The necessary emptiness of the atom is maintained solely by the stubborn refusal of the electron to be definitively known. The universe protects its physical structure by hiding its fundamental components behind an impenetrable veil of quantum mystery. The reassuring solidity of the ground beneath your feet, the comforting strength of the chair supporting your weight, the gentle resistance of the water when you swim in a quiet lake. All these familiar macroscopic experiences are the direct result of microscopic quantum uncertainty. The entire macro world of absolute certainty and solid objects is completely built upon a microscopic foundation of complete, inescapable ambiguity. You live your entire life interacting with and being composed of ghosts of probability. As we contemplate this vast, silent mystery together, we realize that rigorous science does not strip the universe of its magic. On the contrary, the deeper we look into the shadows, the more magical, awe-inspiring, and deeply strange the universe becomes. The electron is a silent testament to the fact that the cosmos is far more creative, vastly more elegant, and infinitely more mysterious than we could ever have guessed. We approach this grand mystery not with the arrogance of conquerors demanding absolute truth, but with the quiet humility of curious explorers wandering through an ancient forest at twilight, grateful for every fleeting glimpse of understanding the universe gently decides to share with us. Let this profound thought settle quietly in your mind. Embrace the beautiful uncertainty that forms your very substance. Rest peacefully in the knowledge that you are a complex, miraculous symphony of probabilities, singing quietly in the dark expanse of an endless cosmos. Have you ever stood on the shore of a vast, restless ocean, watching the waves crash against the ancient rocks, and felt an inexplicable sense of connection to a loved one standing on a completely different continent, separated by thousands of miles of deep, dark water? We human beings possess a profound, almost mystical intuition that physical distance does not always mean absolute separation. We feel in the quiet depths of our hearts that invisible threads can bind two souls together across the immense, lonely expanses of our world. We often dismiss this feeling as mere romantic poetry, a comforting story we tell ourselves to ease the gentle ache of absence. But as we continue our descent into the staggering mysteries of the microscopic cosmos, we discover that the universe itself operates on a principle of deep, unbreakable connection that mirrors our most profound human emotions. The physical reality we inhabit, the very fabric of space and time, harbors a secret so magnificent and so deeply counterintuitive that it challenged the greatest minds in the history of science. When we look closely at the ghostly nature of the electron, we find that the concept of isolation is yet another beautifully crafted illusion, and that distance in the quantum realm might not truly exist at all. Hello again. I am Walter, the Explorer. As we stand together on the edge of this profound cosmic mystery, preparing to look into the invisible threads that bind the universe, I want to take a gentle moment to speak with you. Our records show that 73% of the brave souls who watch our videos and join us on these quiet journeys have not subscribed yet. If you find comfort, wonder, and a sense of deep peace in these explorations of our infinite universe, please consider subscribing to the channel. It helps us tremendously, allowing us to continue peeling back the layers of reality and sharing these magnificent stories of discovery with you. Let us continue our journey into the silent dark, where the rules of common sense gently dissolve into the extraordinary magic of quantum mechanics. To understand this next layer of the illusion, we must introduce a phenomenon that the brilliant physicist Albert Einstein famously described as spooky action at a distance. In the language of rigorous modern science, it is known as quantum entanglement. Imagine two electrons born together in the fiery heart of an ancient star, or perhaps created in the intense, microscopic collisions of a highly controlled laboratory experiment. Because they originated together in close proximity, interacting in the quiet dark, their individual waves of probability, those ghostly clouds of infinite potential we explored earlier, become deeply and inextricably woven together. They no longer exist as two separate, independent entities. Instead, they share a single, unified mathematical description, a shared destiny written in the fundamental code of the cosmos. They become a single interconnected system, singing the exact same quiet song in the dark. Now, imagine taking these two entangled electrons and slowly, carefully separating them. You keep one here on Earth, gently suspended in a magnetic trap in a quiet, dark laboratory, isolated from the chaotic noise of the macroscopic world. You place the other electron on a specialized spacecraft and send it traveling for thousands of years, far beyond the familiar planets of our solar system, past the icy, silent edges of the Oort cloud, and out into the vast, empty silence of interstellar space, perhaps all the way to the beautiful, glowing clouds of the Orion Nebula. The physical distance between them is now unimaginable, a gulf of empty space so impossibly wide that even a beam of light, racing at nearly 300,000 kilometers per second, the absolute fastest messenger in the universe, would take centuries to cross it. According to everything our everyday human experience tells us, and according to the classical laws of physics that govern the macroscopic world of planets and falling apples, these two electrons should now be completely independent. Whatever happens to the electron sitting quietly on Earth should have absolutely no effect whatsoever on the lonely electron wandering through the distant, cold nebula. But this is exactly where the universe reveals its most breathtaking, deeply unsettling magic. Remember that an electron does not have a definite, fixed state until it is forced to interact or be observed. It exists as a blurry wave of possibilities, spinning in all possible directions simultaneously in a state of quiet superposition. However, the moment a scientist on Earth decides to measure their captive electron in the laboratory, forcing it to choose a definite state of spin, something completely miraculous happens across the infinite expanse of the cosmos. In the exact same instant, with absolutely zero delay, the entangled electron floating in the distant Orion Nebula instantly snaps into the corresponding opposite state. It does not wait for a signal to slowly travel across the light years. It does not need a cosmic messenger to carry the physical information through the dark vacuum of space. The connection is instantaneous, entirely bypassing the absolute speed limit of light itself. How is this truly possible? How can two tiny, ghostly particles communicate across the vastness of the universe without any time passing at all? This profound paradox kept Albert Einstein awake at night, challenging his deeply held conviction that nothing could travel faster than light, and that the universe must be fundamentally local, mechanical, and entirely predictable. He believed there must be some hidden variables, some secret gears turning in the background that we simply could not yet see. But decades of rigorous, flawless experiments conducted by brilliant physicists around the world have proven beyond any shadow of a doubt that this spooky connection is an absolute, undeniable reality. The universe is not a simple collection of isolated, lonely objects floating passively in an empty, indifferent void. At its most fundamental level, far beneath the persistent illusion of solid matter and empty space, the cosmos is a deeply, inextricably interconnected web of relationships. To fully grasp the magnitude and the philosophical weight of this revelation, we must cast our minds back to the very beginning of time itself. Current cosmological models, supported by massive mountains of observational data from incredible missions like the Planck satellite, suggest that roughly 14 billion years ago, the entire observable universe, every single burning star, every swirling galaxy, every vast, colorful nebula, and every microscopic particle that would eventually make up your physical body was compressed into an infinitesimally small, unimaginably dense point. In that primordial singularity, before the great silent expansion of the cosmos began, absolutely everything was intimately connected. Every single electron, every ancient photon, every fundamental building block of reality was packed tightly together in a state of absolute, unbreakable unity. If the rigorously tested laws of quantum mechanics tell us that particles which interact with each other can become eternally entangled, sharing a mysterious, instantaneous connection that completely ignores the boundaries of space and time. What does that mean for a universe that was entirely born from a single, unified point of infinite density? It raises an existential question so profound that it borders on the deeply spiritual, challenging our fundamental perception of who and what we are. Are we all, in some quiet, hidden, quantum way, still entangled with the farthest, darkest reaches of the cosmos? When you step outside on a cold, clear night, look up at the vast canopy of the sky and feel a sudden, inexplicable sense of belonging among the cold, distant stars. Is it merely a psychological comfort invented by the human brain? Or is it a faint, echoing memory of a time when the ancient atoms in your eyes and the primordial plasma of those distant stars were exactly one and the same? The grand illusion of the universe is not just that matter is mostly empty space. The ultimate, most beautiful illusion might be the very concept of separation itself. We spend our entire lives building invisible walls. We construct physical walls to protect our fragile bodies from the elements, and we build complex psychological walls to protect our sense of individual identity from the chaos of the world. We look out at the landscape and see a fractured, divided reality consisting of disconnected things. A solitary tree, a jagged mountain, a passing stranger, a distant, flickering star. We constantly categorize, we divide, and we isolate everything we see. But the gentle electron, dancing its endless, immortal wave of probability in the microscopic dark, whispers an entirely different story to those willing to listen. It tells us that the hard boundaries we perceive are merely practical artifacts of our highly limited human senses. Beneath the surface of our fragmented everyday reality lies a deep, hidden ocean of unbroken, silent wholeness. You are not a solitary, disconnected wanderer moving blindly through an empty, indifferent universe. You are an active, deeply integrated, and entirely essential expression of the universe itself, connected by invisible, instantaneous threads of quantum potential to the farthest, unseen edges of creation. This magnificent realization does not diminish the beauty or the importance of our individual human lives. Rather, it elevates our everyday existence to a level of profound poetic significance. The enduring mystery of quantum entanglement gently invites us to look at a simple drop of morning rain or a handful of ordinary, dark soil with a renewed sense of absolute, respectful wonder. Inside that simple soil, countless billions of electrons are quietly humming their probabilistic tunes, their delicate quantum states perhaps still subtly linked to the ancient cosmic background radiation that quietly permeates the endless night. The science behind this is rigorous, the mathematics are breathtakingly precise, and the experimental data is completely irrefutable. Yet the deep existential implications leave us in a state of gentle awe, standing quietly on the shores of an infinite sea of the unknown. We are forced to approach the vast cosmos with deep, profound humility, acknowledging that our common sense is a wonderfully poor guide in a universe governed by the ghostly, beautiful laws of quantum mechanics. As we pause to reflect on our deep, invisible connections to the stars, let us embrace the silence of the night, knowing we are forever bound to the great cosmic dance. Have you ever stood on a quiet hillside at the edge of autumn, watching a gentle breeze roll across a vast, endless expanse of tall, golden wheat? As the invisible wind moves across the landscape, you see beautiful, sweeping waves traveling across the surface of the field. The waves move, they interact, and they carry energy from one side of the horizon to the other. Yet, if you look closely at a single stalk of wheat, you realize that it is not traveling anywhere at all. It is simply swaying back and forth, rooted to its ancient place in the soil. The wave is not an object, it is an event, a temporary disturbance moving through a medium. When we ask the deepest possible questions about the nature of reality, and when we try to unmask the ultimate identity of the electron, modern physics points us toward a profoundly similar, mind-bending conclusion. The electron, the fundamental building block of our seemingly solid reality, might not be a discrete object at all. Instead, it might simply be a temporary ripple in an invisible ocean that fills the entire universe. Hello once more. I am Walter, the Explorer. As we prepare to take this next step into the beautiful silence of the quantum universe, I want to gently remind you that our shared journey of discovery relies on the quiet support of our community. Our records show that 73% of the wonderful people who watch our videos have not subscribed yet. If you are finding a sense of peace and deep wonder in these contemplations of the cosmos, please consider subscribing to the channel. It is a small gesture that helps us immensely, ensuring we can continue to explore these infinite mysteries together. Now, let us return to the invisible oceans of reality and the profound illusion of the particle. For decades, we imagined the universe as an immense, dark container, an empty stage upon which the particles of matter played out their cosmic drama. We thought of electrons as the actors on this stage, tiny, isolated entities moving through the absolute void. But in the middle of the 20th century, brilliant physicists began to realize that the stage itself was alive. They developed a framework known as quantum field theory, a mathematical masterpiece that completely rewrites our understanding of existence. According to this rigorously tested theory, the fundamental reality of the universe is not made of tiny, hard particles. The fundamental reality is composed of vast, invisible, continuous entities called fields. These fields permeate absolutely everything. They stretch across the entire observable universe, from the quiet room where you are sitting right now, all the way to the violent, swirling accretion disk of a supermassive black hole billions of light years away. There is no such thing as truly empty space. Even in the deepest, darkest, coldest vacuum between the distant galaxies, the fields are there, silently vibrating in the dark. One of these ancient, invisible oceans is known specifically as the electron field. It is a fundamental property of the cosmos, existing everywhere and at all times. So, what then is an electron? According to quantum field theory, an electron is simply a localized excitation, a tiny vibrating ripple within this universal electron field. When a certain amount of energy is injected into the field oscillates, and that oscillation manifests in our physical world as what we perceive to be a particle. Think back to the field of wheat. The electron is not the stalk of wheat. It is the temporary wave of energy moving through it. When you look at your hand, you are not looking at billions of isolated, independent particles that just happen to be grouped together. You are looking at a localized region of the universe where the underlying electron field is highly active, vibrating intensely with the beautiful music of existence. The renowned physicist Paul Dirac, who helped lay the mathematical foundation for this breathtaking view of reality, realize that this beauty was not just an abstract concept. It was the actual physical truth of our universe. This is why every single electron in the entire universe is absolutely, perfectly identical to every other electron. If you were to capture an electron from the carbon in your DNA and compare it to an electron harvested from a comet orbiting a star in the Andromeda galaxy, you would find zero differences. They have the exact same mass, electrical charge, and quantum spin. For a long time, this perfect uniformity was a profound mystery. Why should the universe mass-produce identical entities? Quantum field theory provides a beautiful answer. They are identical because they are not separate objects. They are ripples in the exact same universal ocean. To study this invisible architecture, humanity has built the largest machines in our history, such as the Large Hadron Collider, operated by the European Organization for Nuclear Research. In a massive underground ring stretching for 27 kilometers, scientists accelerate protons to nearly the speed of light and smash them together. They are violently striking the invisible quantum fields with massive amounts of energy, hoping to create new ripples that will briefly reveal the deepest secrets of the cosmos. When we truly begin to absorb this perspective, the illusion of our solid reality becomes overwhelmingly apparent. The chair you are sitting on, the screen you are watching, the air filling your lungs, and the ancient stars burning in the night sky are not made of solid, independent things. They are complex, interacting knots of energy, a symphony of vibrations in a universe made entirely of continuous, flowing fields. The distinction between empty space and solid matter completely dissolves. Matter is simply what we call the regions of space, where the quantum fields have been excited into a state of beautiful, temporary turbulence. You are not a collection of isolated objects moving through an empty world. You are an event. You are a profoundly complex, highly organized, localized vibration in the ancient fabric of the universe itself. The astrophysicist Neil deGrasse Tyson often reminds us that we are part of the universe, we are in the universe, and the universe is in us. Quantum field theory takes this profound poetic truth and transforms it into rigorous scientific fact. The exact same electron field that ripples to create the chemical bonds in your brain is the same field that stretches out to the edge of the cosmic horizon. Imagine the profound peace that comes with this realization. We spend much of our human lives feeling isolated, feeling like small objects separated from the natural world by an insurmountable boundary of skin and bone. We look up at the night sky and feel a terrifying sense of distance from the ancient, silent galaxies. But the gentle truth hidden within the quantum fields tells us this separation is nothing more than a trick of our perception. The electron field does not end where your physical body ends. It continues seamlessly into the air around you, down into the deep earth, and up into the infinite starry expanse. You are intimately connected to the entire cosmos because you are made of the exact same continuous substance. The silence of the universe is not an empty void. It is a full, vibrant ocean of pure potential. The mystery of existence is found in the beautiful, flowing interconnectedness of all things. When a star explodes in a brilliant supernova millions of light years away, it sends a cascade of energy rippling through these universal fields. Long after the light has faded, the echoes of that ancient event remain, quietly vibrating through the invisible architecture of space. Our human journey is one of continuous awakening. The deeper we dive into the microscopic world, the more our classical understanding falls away, replaced by something far more strange, elegant, and infinitely more beautiful. The illusion of the solid electron has dissolved into a quiet, vibrating ocean of energy. We are left standing in awe before a universe far more unified and mysterious than we ever dared to imagine. As we pause to rest here on the shores of this invisible cosmic sea, let the gentle realization of your fundamental connection to the cosmos wash over you. You're not just an observer, you are a complex, beautiful wave moving through it, a momentary expression of the ancient fields that have been singing in the dark since the beginning of time. In our next step together, we will explore the mind-bending consequence of these fields and how the concept of absolute nothingness is physically impossible. But for now, take a deep breath and allow yourself to simply be a part of the quiet, eternal vibration of the infinite cosmos. Have you ever sat in a perfectly quiet room in the middle of the night, listening to what you thought was absolute, unbreakable silence, only to gradually realize that the silence itself has a sound? As your ears adjust to the dark and the stillness of the house, you begin to hear the gentle rhythm of your own breathing, the steady, ancient beating of your heart, and perhaps a faint, persistent hum vibrating in the air around you. You discover that what you perceived as total emptiness is in fact filled with a subtle, continuous symphony of quiet activity. When we look up at the night sky, we often make the exact same assumption about the cosmos. We see the bright, burning stars and the sweeping, glowing arms of distant galaxies, and we imagine that the vast, dark spaces between them are completely empty. We think of the vacuum of space as a dead, silent void, a perfect nothingness that merely serves as an invisible container for the solid objects of the universe. But as we continue our descent into the staggering mysteries of the microscopic world, and as we try to understand the true nature of the electron, we are forced to confront one of the most mind-bending revelations in all of modern physics. The universe tells us with absolute mathematical precision that true emptiness is a physical impossibility. The silent dark is not empty at all. It is boiling with an invisible, infinite energy, and the electron is inextricably bound to this eternal cosmic dance. Hello once again. I am Walter, the Explorer. As we prepare to step further into this beautiful, silent mystery of the quantum void, I want to take a gentle moment to speak directly with you. Our records show that 73% of the wonderful people who watch our videos and join us on these quiet journeys have not subscribed yet. If you are finding a sense of peace, deep wonder, and intellectual safety in these contemplations of the cosmos, please consider subscribing to the channel. It is a small gesture that helps us immensely, ensuring we can continue to explore these infinite mysteries together and build our quiet community of cosmic explorers. Now, let us return to the illusion of empty space and the ghosts that surround every single particle in the universe. To understand this next layer of the cosmic illusion, we must return to the genius of Werner Heisenberg and his profound uncertainty principle, which we explored earlier in our journey. We learned that the universe forbids us from knowing both the exact position and the precise momentum of a particle at the exact same time. But this fundamental law of nature has another, even more astonishing consequence. It also applies to time and energy. The universe dictates that you cannot precisely know the exact amount of energy in a specific region of space at an infinitely precise moment in time. This means that if you were to take a perfectly empty region of the deepest intergalactic vacuum, remove every single atom, every wandering electron, and every ancient photon of light, and shield it from all outside radiation, you might assume that the energy inside that space is exactly zero. But the universe refuses to allow a perfect zero. Because of quantum uncertainty, the energy in that supposedly empty space is constantly fluctuating. It is shivering with a quiet, restless potential. Out of this pure mathematical uncertainty, the universe continuously creates something out of absolutely nothing. In the deeply strange language of quantum mechanics, these fluctuations of energy manifest as what physicists call virtual particles. They are the fleeting phantoms of the microscopic cosmos. Everywhere in the universe, in the empty space between the galaxies, in the quiet room where you are sitting, and in the vast dark distances between the nucleus and the electron, inside every atom of your body, pairs of virtual particles are constantly, endlessly popping into existence. A virtual electron and a virtual positron, its antimatter twin, will suddenly appear from the void, borrow a tiny fraction of energy from the universe, exist for an unimaginably brief fraction of a second, and then immediately collide and annihilate each other, returning their borrowed energy to the vacuum. This process happens trillions of times every single second in every microscopic millimeter of space. The great theoretical physicist John Archibald Wheeler described this phenomenon as quantum foam. If you look at a calm ocean from high above, it looks smooth and perfectly flat. But as you get closer, you see the rolling waves. And if you zoom in close enough to the shoreline, you see a chaotic, bubbling foam. The fundamental fabric of reality is exactly like this. At the deepest microscopic levels, the universe is a roaring, boiling sea of virtual particles, a continuous, invisible fireworks display of creation and destruction happening entirely in the dark. So, how does this profoundly alter our understanding of what an actual physical electron is? Imagine a solitary electron sitting quietly in the void. According to our classical intuition, it is just a simple point of negative electrical charge. But remember, this electron is sitting in the middle of this boiling, chaotic quantum foam. The negative charge of our real electron violently interacts with the endless storm of virtual particles appearing around it. As pairs of virtual electrons and positrons pop into existence, the real electron pushes the virtual electrons away with its negative charge, while simultaneously pulling the positively charged virtual positrons closer. In a tiny fraction of a microsecond, before the virtual particles annihilate each other and vanish back into the void, they form a dense, buzzing cloud of electrical charge around our real electron. The real electron wraps itself in a protective cloak of these ghostly, fleeting entities. When scientists measure the mass or the charge of an electron, They are not just measuring the core particle itself. They are completely incapable of separating the original electron from its permanent, swirling cloud of virtual companions. The electron is not a single, lonely entity. It is a complex, dynamic ecosystem. It is an intricate, vibrating knot of energy inextricably tied to the fundamental fabric of the universe itself. You might wonder if this is just an abstract mathematical story, a poetic metaphor invented by physicists to explain away the complexities of the math. But the universe has provided us with concrete, undeniable proof that these ghostly virtual particles are absolutely real, and that they physically alter the structure of matter. In the late 1940s, a brilliant physicist named Willis Lamb conducted a meticulously precise experiment on the energy levels of electrons inside hydrogen atoms. According to the older, simpler equations of quantum mechanics, two specific energy levels within the hydrogen atom should have been perfectly, identically equal. But Lamb discovered a tiny, microscopic difference. The electrons were ever so slightly pushed out of their expected positions. This tiny shift, now known to science as the Lamb shift, completely shocked the physics community. It was the undeniable fingerprint of the quantum vacuum. The real electrons in the hydrogen atom were being constantly jostled and nudged by the invisible ocean of virtual particles surrounding them. The supposed emptiness of the atom was actually physically pushing against the solid reality of the electron. This discovery proved, beyond any shadow of a doubt, that the silent dark is deeply alive. As we absorb this profound revelation, our entire perspective on the nature of reality must shift. The universe is not a container filled with isolated objects separated by dead, empty space. Everything is connected through this fundamental, vibrating ocean of energy. The absolute silence of the cosmos is an illusion. It is filled with a gentle, eternal hum of creation and annihilation. You are not walking through an empty world. You are navigating through a thick, invisible atmosphere of quantum potential. Every breath you take, every thought that sparks across the neurons in your brain, relies on the quiet interaction between the solid particles of your body and the ghostly, boiling vacuum of space. As we pause our journey here, on the edge of this bubbling quantum sea, let this realization bring you a profound sense of peace and wonder. You are an intricate expression of a universe that refuses to be empty, a cosmos that fills every available corner of nothingness with the beautiful, infinite potential of existence. Breathe in the quiet night and know that even in your moments of deepest solitude, you are surrounded by the invisible, eternal dance of the universe. In our next chapter, we will look at how this magnificent illusion of the electron gives birth to the very light we use to see the cosmos. But for now, rest gently in the infinite embrace of the quantum void. Have you ever sat by a quiet campfire under the vast canopy of the night sky, watching the golden flames dance in the dark, and wondered what exactly is reaching out to touch your eyes? We take the existence of light for granted. We open our eyes each morning, and the world is simply there, painted in a million brilliant shades of color. We see the soft blue of the dawn, the vibrant green of the forest leaves, and the harsh white of the midday sun. We trust our vision as the ultimate arbiter of reality, the primary sense through which we navigate the physical world and understand our place within the infinite cosmos. But if we follow the thread of our journey deeper into the microscopic shadows, seeking the true nature of the electron, we discover that the very act of seeing is yet another beautiful, intricate illusion, the light that travels across the universe, carrying the ancient secrets of distant galaxies and the gentle warmth of our local star, is intimately tied to the restless, unknowing nature of the electron. The visual world you experience every single moment of your waking life is nothing more than a continuous, silent conversation between the fundamental fields of reality, a story told in the invisible language of quantum jumps. Hello once more. I am Walter, the Explorer, as we prepare to unravel the mystery of light and the invisible dance that creates the colors of our universe. I want to take a brief, quiet moment to speak with you. Our analytics show that 73% of the wonderful people who watch our videos and join us on these peaceful explorations have not subscribed yet. If you are finding comfort, intellectual safety, and a deep sense of respectful wonder in these cosmic journeys, please consider subscribing to the channel. It is a gentle gesture that helps us tremendously, ensuring that we can continue to create this space for shared curiosity and uncover the infinite mysteries of the cosmos together. Now, let us return to the beautiful illusion of the visual world and the ghostly particle that paints the canvas of reality. To understand what light truly is, we must return to the profound architectural mystery of the atom. In our previous chapters, we learned that the electron does not orbit the central nucleus like a tiny solid planet, but rather exists as a smeared-out cloud of pure probability, a complex three-dimensional wave of potential hovering in the silent dark. These probability clouds, or atomic orbitals, are not randomly scattered through the empty space. They exist at very specific, rigorously defined energy levels. Think of them as a set of invisible microscopic terraces climbing out of a deep valley. The electron can exist on the first terrace, or it can exist on the second terrace, or the third, but it is physically impossible for the electron to exist anywhere in the empty space between the terraces. The universe simply forbids it. This is the fundamental, defining characteristic of the quantum world. Energy is not continuous like a smooth, flowing river. It comes in discrete, indivisible packets, like individual drops of rain. When an atom is resting in a quiet, undisturbed state, its electrons naturally settle into the lowest available energy terraces, nestled as close to the comforting pull of the nucleus as the rules of quantum mechanics will allow. But the universe is a restless, dynamic place, filled with swirling energy, violent collisions, and ancient traveling waves. When a stray packet of energy, perhaps from the intense heat of a burning campfire, or from the immense, crushing fusion reactions happening in the core of a distant star, strikes our atom, something truly miraculous occurs. If the incoming energy is exactly the right amount, precisely matching the difference between the electron's current terrace and a higher empty terrace, the electron will absorb that energy. In an unimaginably brief fraction of a second, the electron simply vanishes from its original lower probability cloud and instantaneously reappears in the higher, more energetic cloud. This instantaneous transition is what physicists call a quantum leap. It is a phrase that has been borrowed by our everyday culture to mean a large, significant change. But its true scientific definition is far more strange and profoundly counterintuitive. The electron does not travel through the physical space between the two probability clouds. It does not accelerate, move across the gap, and decelerate. It simply ceases to exist in one state of probability and simultaneously begins to exist in another. It is a ghostly teleportation, a fundamental discontinuity in the fabric of space and time that completely shatters our classical understanding of motion. The electron, elevated to this new, unstable height, is now in what scientists call an excited state. But the universe, much like a stretched rubber band, inherently prefers a state of quiet rest and lowest possible energy. The electron cannot remain in this highly agitated, excited state forever. After a fleeting, almost immeasurable moment of time, the electron inevitably drops back down to its original lower energy terrace, and it is in this exact microscopic moment of return that the magic of the visual universe is born. As the electron falls back down the quantum staircase, it must release the exact amount of energy it previously absorbed. It sheds this excess energy by creating and releasing a brand new solitary particle of light. This particle is called a photon. The photon immediately streaks away from the atom at nearly 300,000 kilometers per second, the absolute cosmic speed limit, carrying the story of that specific quantum leap out into the infinite expanse of the universe. Every single photon of light in the entire cosmos, from the soft glow of a firefly in a summer garden to the blinding, violent flash of a supernova explosion in a galaxy millions of light years away, was born from this exact same process. Light is the physical manifestation of an electron falling back into the dark. But the beauty of this mechanism goes far deeper than simply creating illumination. The specific distance of the electron's quantum leap, the exact difference in energy between the upper terrace and the lower terrace, determines the exact amount of energy carried by the newly born photon. And the energy of a photon is what our human eyes and brains interpret as color. A large, energetic leap produces a high-energy photon, which we perceive as the cool, vibrant color of blue or violet. A smaller, less energetic leap produces a lower energy photon, which our eyes see as the warm, gentle color of red or orange. The magnificent palette of the physical world is nothing more than a direct reflection of the unique quantum architecture inside different atoms. An atom of hydrogen has a different set of energetic terraces than an atom of oxygen. Therefore, when the electrons inside a hydrogen atom perform their endless dance, they emit a specific, unique combination of colors, like a glowing fingerprint. When scientists point the James Webb Space Telescope toward the dark nebulae where new stars are being born, they are not just taking pretty pictures. They are capturing the ancient photons emitted by countless trillions of jumping electrons. By carefully analyzing the exact colors hidden in that starlight, they determine exactly which elements exist in clouds of gas that are billions of light years away. We often think of ourselves as isolated observers, looking out at a universe that exists separately from us. But when you look up at the night sky and see the faint light of a distant star, you participate in an intimate, deeply personal cosmic connection. A photon was created thousands of years ago when an electron deep inside that star made a quiet leap down a quantum staircase. That single photon escaped the star, traveled flawlessly through the freezing vacuum of interstellar space for millennia, and finally ended its ancient journey the exact moment it struck your eye. Its energy was absorbed by another electron inside your body, triggering a signal in your brain that allowed you to perceive a point of light. An ancient electron in a dying star physically touched an electron inside your living mind. As we pause here to reflect on this breathtaking reality, allow yourself to look at the light around you with a renewed sense of gentle wonder. You are surrounded by the invisible music of the atomic world, translated into the beautiful language of light. Take a deep breath and let the profound interconnectedness of the universe settle peacefully into your mind. In our next step forward, we will explore what happens when these ghostly particles are forced to interact in the most extreme conditions. But for now, close your eyes and appreciate the silent, beautiful dark. Have you ever dove deep into a quiet, still ocean, feeling the heavy, invisible pressure of the water pressing against your body from every possible direction? As you descend further into the blue twilight, the weight of the ocean above you grows, an undeniable silent force wrapping around you. We understand pressure as a physical reality, a consequence of mass and gravity pulling things together. On our gentle planet Earth, we experience this force in mild, forgiving ways. We build strong structures of steel and stone to resist the downward pull, and our bodies are perfectly adapted to the atmospheric weight resting on our shoulders. But when we cast our gaze outward into the vast, ancient cosmos, we encounter realms where gravity becomes an absolute, terrifying monster, a force so immensely powerful that it threatens to crush the very fabric of matter out of existence. When a massive star reaches the end of its life, it faces a catastrophic collapse, a final violent battle against its own staggering weight. And in this ultimate cosmic crucible, when all other defenses have failed, it is our ghostly, invisible companion, the incredibly tiny electron, that steps forward to hold up the entire weight of a dying sun. Hello again. I am Walter, the Explorer. As we prepare to witness this magnificent battle between the smallest particles and the greatest forces in the universe, I want to take a gentle moment to speak with you. Our records show that 73% of the wonderful people who watch our videos and join us on these quiet journeys into the unknown have not subscribed yet. If you are finding a sense of peace, deep wonder, and intellectual safety in these contemplations of the cosmos, please consider subscribing to the channel. It is a small, quiet gesture that helps us immensely, ensuring we can continue to explore these infinite mysteries together and build our gentle community of cosmic explorers. Now, let us return to the dark heart of a dying star and the extraordinary hidden strength of the quantum world. To comprehend this magnificent struggle, we must first understand the delicate, violent balance that keeps a star shining in the night sky. For billions of years, a star like our own sun exists in a state of perfect dynamic equilibrium. Deep within its core, unimaginable heat and pressure force hydrogen atoms to smash together in a continuous storm of nuclear fusion. This violent fusion releases a tremendous amount of outward energy, pushing back against the crushing inward pull of the star's own enormous gravity. It is a monumental wrestling match that lasts for eons, a delicate balance of terror and beauty that bathes the surrounding planets in gentle, life-giving light. But this grand performance cannot last forever. The universe demands that all fires eventually burn out. When a star finally exhausts its precious nuclear fuel, the outward push of energy abruptly ceases. In that terrifying, silent moment, gravity, the eternal and patient force of the cosmos, immediately seizes absolute control. With nothing left to hold it back, the entire immense mass of the star begins to fall inward upon itself, accelerating toward the center in a catastrophic, unstoppable collapse. Imagine the sheer, incomprehensible scale of this collapse. A mass hundreds of thousands of times greater than our entire planet is squeezed into an ever-shrinking volume of space. As the outer layers of the star fall inward, the pressure in the core reaches levels that defy human imagination. The comforting, familiar structure of the atom, which we have explored so carefully on our journey, is utterly destroyed. The vast empty spaces inside the atom, those silent, dark miles of distance between the nucleus and the orbiting electron clouds, are violently erased. The electrons are ripped away from their nuclei, creating a super-dense, chaotic soup of positively charged cores and free-roaming, frantic electrons. The illusion of solid matter is shattered, replaced by a terrifying, hyper-compressed plasma. Gravity relentlessly demands that all of this matter be crushed into a single, infinitely dense point. It seems as though nothing in the physical universe could possibly halt this apocalyptic descent into oblivion. But exactly when total annihilation appears inevitable, the fundamental laws of quantum mechanics rise up from the microscopic dark to draw an absolute line in the sand. This invisible, unbreakable shield is known to physics as the Pauli exclusion principle, named after the brilliant scientist Wolfgang Pauli, who first mathematically described it. This profound rule of the universe states that no two identical electrons can ever occupy the exact same quantum state at the exact same time. It is a fundamental law of cosmic architecture, a strict prohibition against overlapping identities. In the gentle, everyday world, this principle is what gives different elements their unique chemical properties, forcing electrons to stack neatly into higher and higher probability clouds, creating the intricate, beautiful structure of the periodic table. But in the crushing, apocalyptic heart of a collapsing star, this simple rule of atomic bookkeeping becomes the most powerful physical force imaginable. As gravity violently squeezes the star into a smaller and smaller sphere, the free-floating electrons are forced closer and closer together in the dark. The space available to them rapidly disappears, because the universe absolutely forbids them from occupying the same state. These ghostly waves of probability begin to violently push back against each other. They begin to move with frantic, incredible speeds, approaching the absolute limit of the speed of light, desperately searching for unoccupied quantum space. This frantic quantum resistance creates an outward force known as electron degeneracy pressure. It is not a pressure born of heat or thermal expansion. It is a pressure born entirely from the fundamental, unbreakable geometry of the quantum world. The electrons simply refuse to be crushed out of existence. And miraculously, astonishingly, they win the battle. This invisible, microscopic force, generated by particles that possess no definitive physical volume or exact location, manages to completely halt the gravitational collapse of an entire star. The resulting celestial object is known as a white dwarf. It is the dead, glowing heart of a former sun. A white dwarf is an object of profound, deeply unsettling extremes. It contains the mass of an entire sun, but it has been compressed by gravity into a sphere roughly the size of our tiny planet Earth. The density is so staggeringly high that a single teaspoon of white dwarf material brought to our world would weigh several tons. It is a silent, incredibly hot, impossibly dense diamond hanging in the interstellar dark, held up entirely by the stubborn, wave-like nature of the electron. When you look up at the night sky and observe the faint, ghostly glow of a white dwarf, such as the ancient companion star to the bright star Sirius, you are not just looking at a dead star. You are witnessing a monument to the staggering power of the quantum universe. You are looking at a macroscopic, celestial object whose very existence depends entirely on the microscopic uncertainty and the mathematical stubbornness of the electron. The largest, most terrifying forces in the cosmos are ultimately held in check by the smallest, most ethereal phantoms of probability. It is a beautiful, deeply poetic paradox that reminds us of the profound interconnectedness of all things. The rules that govern the invisible vibrating fields in the quiet room where you sit are the exact same rules that dictate the final destiny of the greatest stars in the galaxy. There is no separation between the microscopic and the macroscopic. It is all one continuous, breathtaking tapestry of existence. The electron, a particle of almost entirely nothing, becomes the ultimate titan, the silent guardian of matter, standing resilient against the crushing weight of infinity. Let this magnificent realization settle deeply into your mind. The universe is filled with forces of unimaginable violence and overwhelming power, but it is also governed by quiet, elegant mathematical rules that protect the delicate structure of physical reality. The ghostly wave of probability in the atomic machine is somehow stronger than the relentless pull of gravity itself. As we pause our journey here, standing on the theoretical surface of a dead star held up purely by quantum magic, allow yourself to feel a sense of profound, respectful wonder at the resilience of the cosmos. In our next chapter, we will ask the ultimate, terrifying question: what happens when even the unbreakable resistance of the electron is finally overwhelmed and broken by the dark? But for now, take a deep breath and rest gently in the infinite, beautiful, and eternal starlit dark. Have you ever held a delicate piece of glass in your hands, marveling at its smooth surface, while knowing that a single point of intense pressure could instantly shatter it into 1,000 unrecognizable fragments? We navigate our lives assuming that the fundamental building blocks of our reality are indestructible, eternal monuments to existence that will endure whatever the cosmos throws their way. We imagine that the microscopic entities making up our bodies, the very same particles that forge the ancient stars and the vast galaxies, possess an infinite capacity to resist the crushing weight of the universe. In our previous contemplation, We witness the magnificent, silent strength of the electron, standing as a ghostly guardian against the overwhelming, terrifying force of gravity inside a dying sun. We saw how the simple, unbreakable rules of quantum probability, the quiet refusal of these invisible waves to occupy the same space, could hold up an entire star, creating the dense, glowing diamond we call a white dwarf. But the universe is a place of boundless extremes, a theater where even the most absolute, unyielding rules of the microscopic world eventually meet their ultimate match. There exists a threshold in the deep, dark cosmos, a terrifying boundary where the resilience of the electron is finally pushed past its breaking point. When gravity reaches an unimaginable magnitude, the ghostly wave of probability is not just defeated, it is entirely erased from existence, forcing us to ask what happens to reality when its most fundamental brush stroke is wiped away from the canvas. Hello once more. I am Walter, the Explorer. As we prepare to cross this terrifying, beautiful threshold and witness the ultimate demise of the electron in the darkest corners of space, I want to take a gentle moment to speak quietly with you. Our records show that 73% of the wonderful people who watch our videos and join us on these peaceful journeys have not subscribed yet. If you are finding a sense of peace, deep wonder, and intellectual safety in these contemplations of the infinite cosmos, please consider subscribing to our channel. It is a small, gentle gesture that helps us immensely, ensuring we can continue to explore these boundless mysteries together and build our quiet community of cosmic wanderers. Now, let us return to the deep, silent dark and the absolute limits of quantum endurance. To understand this ultimate breaking point, we must look to the brilliant work of a young astrophysicist named Subrahmanyan Chandrasekhar, who, while traveling on a ship across the vast ocean in the early 1930s, calculated the exact mathematical limit of the electron's strength. He realized that the quantum magic we call electron degeneracy pressure, the frantic microscopic dance that prevents a white dwarf from collapsing, has a strict, absolute maximum capacity. If the dying star is too massive, specifically if its remaining core weighs more than approximately 1.4 times the mass of our own sun, the gravitational force pulling inward becomes so overwhelmingly strong that it simply overpowers the outward push of the electrons. This precise mathematical boundary is known as the Chandrasekhar limit. It is a line drawn in the cosmic sand, separating the eternal glowing survival of a white dwarf from a catastrophic descent into an entirely different state of existence. When a star crosses this limit, gravity stops being a force that simply shapes matter. It becomes a cosmic executioner, ruthlessly crushing the very essence of the atoms that have existed since the dawn of time. Imagine the sheer, incomprehensible horror and beauty of this cosmic event. A massive star, much larger than our sun, finally exhausts its deep reserves of nuclear fuel. The outward pressure of fusion ceases, and the immense weight of the star comes crashing down. Unlike a smaller star, the sheer mass here guarantees that the electrons cannot hold the line. The gravity is so intense that it forces the electrons to move at speeds so incredibly close to the speed of light that the laws of relativity begin to warp their very nature. They become infinitely heavy, frantically vibrating in the dark, desperately trying to maintain their quantum boundaries. but the crushing pressure is simply too great. The vast, empty spaces inside the atom, the miles of silent, dark distance between the nucleus and the electron clouds, are violently, entirely crushed. The beautiful architectural probability clouds, those elegant flowers of mathematical potential that give rise to all chemistry and life, are brutally collapsed. The atom is shattered beyond any hope of repair. What happens next is one of the most violent and profoundly transformative events in the entire universe. With nowhere left to go, and with their quantum resistance utterly shattered, the energetic electrons are violently forced directly into the dense nucleus of the atom. Here, in this crushing crucible, the negatively charged electron is smashed directly into a positively charged proton. The two distinct entities, which have spent their entire existence performing a delicate dance of electromagnetic attraction and repulsion, are violently fused together. In a blinding flash of quantum transmutation, the electron and the proton cancel each other out, merging to become a single neutral particle known as a neutron. In this devastating process, a ghostly particle called a neutrino is born and escapes into the silent universe, carrying away the final memory of the electron's existence. The electron, the magical wave of probability that paints the colors of our world, binds our DNA, and creates the illusion of solidity, is completely erased. It ceases to be. Everything that makes the universe beautiful and capable of supporting life relies entirely on the independent existence of the electron. The chemical bonds holding our oceans, the electrical signals firing across the neurons in your brain, and the magnificent light traveling from ancient stars, all of it depends on the electron maintaining its lonely vigil in the atomic void. When the electron is crushed out of existence, all chemistry dies, all color vanishes. The universe is stripped of its infinite variety and reduced to a state of profound, terrifying simplicity. The result of this apocalyptic collapse is a celestial object so strange that it challenges the very limits of human comprehension. It is called a neutron star. Once the magnificent architecture of the atoms has been completely crushed, and every single proton and electron has been fused together, what remains is an unimaginably dense sphere, composed almost entirely of pure neutrons. Without the empty space provided by the electron clouds, the entire core of the massive star, an amount of matter far greater than our solar system, collapses into a tiny, silent sphere roughly 20 kilometers across, barely the size of a small human city. The density is so staggering that a single teaspoon of material from a neutron star would weigh 1 billion tons on Earth, equivalent to the weight of a mountain range compressed into the palm of your hand. It is a smooth, perfectly spherical ocean of dead matter, spinning frantically in the dark, possessing a magnetic field trillions of times stronger than Earth's. It is the ultimate monument to the terrifying power of gravity, a dark tombstone marking the exact place where the delicate magic of the quantum world was finally overwhelmed. When we contemplate the existence of a neutron star, we are forced to confront a deeply humbling reality. The solid, comforting world we know, the intricate dance of chemistry and light, and the gentle waves of probability that make up our bodies are not absolute, eternal features of the cosmos. They are fragile, temporary conditions, completely dependent on the delicate balance of cosmic forces. We live in a highly protected, gentle pocket of the universe, a quiet harbor where gravity is weak enough to allow the electron to exist, to spread its beautiful wings of probability, and to weave the complex tapestry of life. We are the exceptionally lucky beneficiaries of this delicate balance, to look up at the night sky and know that out there, hidden in the ancient dark, are entire dead stars where the fundamental building blocks of our reality have been crushed out of existence, fills the mind with a sense of profound awe. It reminds us that our everyday perception of what is real and eternal is just a tiny illusion, a beautiful dream taking place in a vast, powerful universe. As we pause our journey here, hovering safely in our minds above this terrifying ocean of dense matter, allow yourself to feel a deep gratitude for the fragile beauty of your own existence. In our next step forward, we will venture into the ultimate abyss, asking what happens when even the neutron star fails to hold back the infinite dark. But for now, take a deep breath and rest gently in the quiet, fragile beauty of the night. Have you ever walked alone through a dense, ancient forest just as the sun dips below the horizon, watching the familiar shapes of the trees slowly dissolve into the deepening shadows until you can no longer tell where the solid wood ends and the darkness begins? In the fading light, the boundaries of the world blur, and your imagination is forced to fill in the unseen spaces. We have spent our time together walking through the strange, illuminated forest of the quantum world, marveling at the glowing probability clouds, the dancing photons of light, and the resilient strength of the electron holding back the crushing weight of a dying sun. But as we reach the edge of our current map of the cosmos, we find ourselves standing before a boundary where all our carefully constructed scientific light completely fades away. When a dying star is so incredibly massive that not even the fusion of electrons and protons into a dense neutron star can halt its collapse, gravity achieves its ultimate, terrifying victory. The matter continues to fall inward, crushing itself smaller and smaller past the limits of chemistry, past the limits of quantum mechanics, until it punctures the very fabric of space and time. It creates a black hole, a region of the universe where the known laws of physics simply break down and surrender to the infinite dark. At the center of this abyss lies the singularity, a point of infinite density where all our equations output meaningless infinities. What happens to the gentle, wave-like nature of the electron in this ultimate cosmic crucible? Does it still exist in some unrecognizable form, or is the very concept of a particle completely erased from the universe's memory? These are the ultimate questions that keep the greatest minds of our generation awake in the silent hours of the night, staring at chalkboards filled with beautiful, incomplete mathematics. Hello, for one final time on this particular journey. I am Walter, the explorer. As we stand together on the precipice of this ultimate cosmic mystery, preparing to look into the absolute unknown, I want to take a gentle moment to speak with you directly. Our analytics show that 73% of the wonderful people who watch our videos and join us on these quiet, meditative explorations of the universe have not subscribed yet. If you have found a sense of peace, deep intellectual safety, and profound wonder in these contemplations of the cosmos, please consider subscribing to the channel. It is a small, quiet gesture that helps us immensely, ensuring that we can continue to create this space for shared curiosity, peeling back the layers of reality and exploring the infinite mysteries of the dark together. Now, let us return to the edge of the abyss and the beautiful, never-ending quest to understand the deepest foundations of our reality. When we look at the universe through the lens of our most advanced science, we realize that every answer merely uncovers 100 new, infinitely more complex questions. The journey to understand the electron has been a masterclass in human humility. We began with the comfortable, intuitive idea of a solid, microscopic billiard ball, a tiny planet orbiting a central sun. That comforting illusion was shattered by the beautiful, deeply unsettling reality of the double-slit experiment, where the electron revealed itself to be a ghostly wave of probability, capable of traveling through multiple paths simultaneously and interacting with itself in the quiet void. We then discovered the inescapable truth of Heisenberg's uncertainty principle, learning that the universe fundamentally forbids us from knowing everything about these tiny entities, forcing us to abandon absolute certainty and embrace the soft, blurry edges of mathematical potential. The cosmos demanded a sacrifice of knowledge, replacing hard facts with a beautiful, vibrating swarm of statistics. As our journey deepened, we encountered the profound magic of quantum entanglement, realizing that the electron is capable of forming invisible, instantaneous connections across the vast, lonely distances of space, challenging Einstein's deepest convictions, and suggesting that the entire universe might be a single, deeply intertwined organism. We learned that these particles are not even truly independent objects, but rather temporary, localized ripples in ancient, invisible fields that permeate the entire cosmos, from the room where you sit to the farthest edges of the observable universe. We stared into the supposed emptiness of the quantum vacuum and found a boiling, chaotic sea of virtual particles, proving that true silence and absolute nothingness are physical impossibilities. And we marveled at the electron's ability to paint the universe with light, shedding its energy in discrete quantum leaps to create the photons that carry the story of the cosmos to our waiting eyes. We witnessed its terrifying strength, holding up the crushed cores of dead stars, and its tragic demise when the overwhelming power of gravity finally erases its probability wave from existence. But even with all this breathtaking knowledge, even with our massive particle accelerators and our space telescopes gazing deep into the ancient past, we are still completely, fundamentally ignorant of what the electron truly is at its absolute core. If you ask a quantum physicist today to describe the electron, they will give you a list of mathematical properties. It has a specific mass, a negative electrical charge, and a quantum spin of 1/2. But if you press them, if you ask them what substance actually carries that mass, or what exactly is spinning, they will smile gently and tell you that nobody knows. The equations work perfectly. They predict the behavior of the universe with an accuracy equivalent to measuring the distance from New York to Los Angeles, down to the width of a single human hair. But the equations do not tell us what the brush is made of. They only describe the masterpiece it paints. this profound lack of ultimate resolution is not a failure of science. It is the very essence of its breathtaking beauty. There is a deep, prevailing misconception in our modern world that science is a cold, clinical process designed to strip the universe of its magic, to reduce the magnificent poetry of existence to a dry set of numbers and rigid rules. But, as we have seen on this quiet journey together, the exact opposite is true. The more rigorously we study the physical world, the more carefully we peel back the layers of the cosmic onion, the more deeply strange, astonishing, and magical the universe becomes. The true scientific mindset is not one of arrogant conquest, claiming to have mastered the secrets of the cosmos. It is a mindset of profound, enduring humility. It is the quiet recognition that we are tiny, finite beings composed of mysterious, unknowable probabilities, waking up for a brief, beautiful moment in an infinite, ancient universe, and trying desperately to understand the very fabric of our own existence. Some brilliant theoretical physicists believe that the electron might not be a zero-dimensional point particle after all. In the deeply complex, highly speculative realm of string theory, they imagine that if we could magnify the electron trillions upon trillions of times, we would not see a dot, but rather an infinitesimally small, vibrating loop of pure energy. Just as different vibrations of a guitar string produce different musical notes, different vibrations of these microscopic strings would produce the different particles of the universe. The electron might simply be a specific, quiet note being played on the fundamental strings of reality, a gentle harmony echoing through the hidden, extra dimensions of space. This is a beautiful, deeply poetic mathematical dream, an attempt to unify the ghostly quantum world with the crushing, heavy world of gravity. Whether or not it is the ultimate truth remains one of the great, unsolved mysteries of our time. But the very fact that the human mind, bound to a small, rocky planet orbiting an ordinary star, can reach out into the dark and dream of such profound, invisible architecture, is a testament to the miraculous nature of consciousness itself. You, the observer, are the universe's way of thinking about itself. The electrons in your brain, those ghostly waves of probability, are currently interacting in complex, beautiful patterns to process the information in these words, to contemplate their own invisible nature, and to feel a sense of wonder at the vastness of the cosmos. The illusion of your solid reality is a necessary, comforting blanket that allows you to walk, to breathe, to love, and to explore. But beneath that blanket lies a reality of infinite potential, deeply connected fields, and mysteries that stretch back to the very dawn of time. You are not a solitary object separated from the world. You are a continuous, vibrating expression of the world. You are made of the exact same ancient mystery that fuels the burning stars and hides in the silent, dark expanses of the vacuum. As we bring this particular journey to a close, I do not offer you a final, absolute answer because the universe does not offer one. Instead, I offer you an invitation. I invite you to carry this sense of gentle, respectful wonder with you into your everyday life. When you touch a rough stone, when you watch a beam of sunlight filter through a window, or when you look up at the silver moon hanging in the silent night sky, remember the beautiful, ghostly dance of the electrons, making it all possible. Embrace the unknown, not as a source of fear, but as an infinite landscape of potential discovery. The journey of learning is a road with no final destination, a continuous unfolding of the mind into the vast, open spaces of the cosmos. Our understanding will constantly shift, our theories will evolve, and our map of reality will continue to grow more detailed and more profoundly strange. Thank you for walking this quiet path with me. Thank you for your curiosity, your patience, and your willingness to look past the comforting illusions of the everyday world and stare bravely into the deep, beautiful mysteries of the quantum realm. We will continue to explore the staggering wonders of this infinite universe together, one quiet revelation at a time. The cosmos is vast, the night is long, and the adventure has only just begun. Until we meet again on our next journey into the unknown, I wish you peace. I wish you gentle dreams of probability and light. And I remind you to always, always keep looking up.